Hi everybody, welcome back to our series of videos on piecewise defined functions. So we're going to graph continuous piecewise defined functions in this graph, and so there's a term we haven't defined in this course before, which is continuous. And we're not going to give a proper definition. You can't do that until a future course. But for right now, we have this kind of intuitive definition. So that's why I put it in quotes. A function is continuous if you draw its graph without lifting your pencil off the paper. So graphs like this, for example, are continuous. But if you have to make some sort of break like this, or say, let's do something like this. So something like this, for example, where you have a vertical asymptote, that's a break. That is not a continuous function because I had to break up the function. So these functions are not going to have breaks in them. So the procedure for graphing piecewise defined function in any of these videos is basically this. Graph each piece as you normally would using transformations. Then you delete the part of the graph which you don't need. And then you move on to the next piece and do the same thing. So let's see how that works with this example. So let me change my eraser mode first before we do this, because I don't want, let's say a medium eraser. That works. So let's draw. Now let's put me on our drawing pen. So the first thing we want to do is we want to graph this function. So the first thing we do is we're going to graph 2x minus 1. So this has a so let's put in our scale. So we'll put in a 1 here and a 1 here. And so notice that this line has a slope or has a y-intercept at 0, -1. So we'll put a point here. Then we'll go up over 2, up over 2, up over 2, up over 2. Several times to plot the other points of this line here. Then we'll just draw one nice straight line that connects them all. Alright, that's good. So now what we want to do now is now we don't want to consider this part anymore. Now we just want to consider this part. We want all the values less than or equal to 3. So notice that 3 is right here. So we want to delete any part of the graph that is corresponding to any values of x that is greater than 3. So we want to delete this part of the graph. And notice that since we don't have a quality, we're going to put an open circle right here. And that's going to represent the fact that the function is not defined on this line at x equals 3. It may be defined in other pieces, but not on this piece. So now let's change colors and talk about the next graph. So the next graph we're going to look at is x plus 2. So we are going to go to the y-intercept 0, 2, and then we're going to up and over 1, up and over 1, up and over 1, up and over 1 in both directions, down and over 1 in the other direction. And we're going to get this nice line right here. And then we do the same thing before. Now we're done with this part. Now we'll think about this part. And we want to keep all the parts that are greater than or equal to 3. So again, our 3 is on this line, so we want to get rid of all these parts. So yeah, I'm going to have to redraw some of this, but for the most part. So let's fill that back in, give us our scale, fill that back in, and then let's put in this piece back in. And then we want to, since there's equality here, we're going to put a solid dot here. So notice that this is what the graph of this looks like. For everything less than 3, we are looking like the first line right here. Everything greater than or equal to we're look like here. And notice that this is a continuous function because this green part here filled in the open red circles. So that's what makes it continuous, because now if I just draw with a different color, so let's draw in blue over this. So if I just draw my function in, when I get to x equals 3, all I have to do is change direction, and I don't have to lift my pencil off the paper here. So that's what it means to be continuous, and this is why this is an example of a continuous piecewise defined function. Now, again, continuous functions can have more than two pieces. They can have as many pieces as they want. The only requirement is they always line up like things did right here. So we'll move on to our next video about discontinuous piecewise defined functions. See you then.